Hello again! In the last video, we set the player up so that the character could collect the pickups and gain power from those pickups. In this video, we are going to add the logic in the game mode so that the player's power is drained over time. And the way we're going to do that is to put some code in the game mode, and then we're going to flip back over to the editor and do a couple of last things and then set it up so it'll run. Let's go ahead and get started. The first thing we're going to do is go over to Visual Studio to check out our game mode. So I'm going to flip over to that. And here in our game mode header, the way we're going to do this is a couple of things we need to do. First of all, we need to drain power over time. And part of this is going to be like Epic's version of this tutorial for single player, and part of this is going to diverge again as we do some of our own stuff. So the first thing we need is a decay rate, and that is how quickly we're going to drain power. So we're going to put that in the protected section, and we're going to make that we'll just a float called decay rate, and this is going to be a U property, and we're going to make it U property, edit defaults only. We'll talk about that in a minute. Blueprint read write. We'll put it in the power category, and we'll use our meta tag for blueprint protected. Set that equals true. Okay, now let's add a remark real quick. The decay rate is going to be it's the rate at which the character loses power, and that is done as a percentage of the initial power per second is the way we're going to do that. So this is the rate at which characters lose power, which is a percentage of the character's initial power per second. Okay, so edit defaults only, if we haven't seen this before, means that you can edit the default values for the class or the type. So if we go in the values in the blueprint, we can edit those, but in an instance of the object in the world, you can't edit that. So it only allows you to edit the defaults. Okay, so now we have a decay rate. We need a way to get at that data. Specifically, we want it in the editor, so that's going to be a get decay rate. And that is a U function, so we want to access that from blueprint, and that should be blueprint pure. And we'll put that in the power category. And this is get the current rate of decay, which is percent of initial power per second. Okay, and so that is the function we need so we can get access to this. Oh, let's do it. Go ahead and do. I'm going to do my shortcut implementation and just return decay rate. Save and exit. Boom, that's implemented. Nice and quick. Okay, and so now we need to talk about how we're going to handle draining power. In Epic's version of this tutorial, they do it in the tick function, and that is perfectly reasonable for their purposes. However, I'm going to tell you that as a general rule of thumb, you want to avoid putting complex logic in tick functions because you can really bog down your game, especially in some cases where you have a lot of these types of actors. Now, you could argue that this is the game mode, there's only one of them, it only exists on the server, and we're really only affecting a few players to drain some power over time. And that is all true. But I don't think it's a good idea to get into the habit of executing a bunch of logic in the tick function, so we are not going to do that. But we still want to accomplish the same goal. We want to be able to drain power over time and have it be a kind of a continuous thing as if it were happening in a kind of tick way. But the other thing is, we don't need that to happen. Let's say we're running the game at 60 frames per second. We really don't need to update the player's power level 60 times a second, especially when that's a replicated value. It's just not useful to us. Now, there could be some games where that is true. Maybe in a shooter, maybe in a fighting game, maybe in some cases where you really do need that kind of accuracy and that resolution and that kind of time step. But for us, it's not really necessary. So we are going to make a big performance trade-off. We're going to trade off the frequency of that update for running the code fewer times per second, thereby gaining ourselves some efficiency, both in execution, though it is minimal, of course, given the number of characters that we're talking about. But we also gain some benefit by not overloading the network by replicating this value over and over and over and over and over. Okay, so how are we going to do that? Well, we are going to use a timer. And we're going to do this similar to the way that we set up in the pickups to use a timer. But in this case, we're going to actually set it up to loop for us, and it'll call that, the engine will call us automatically, almost like a tick. But what we'll get is a value for the frequency of that call that we can edit later in the editor, which is also a nice benefit. So let's go ahead and get to it. The first thing we're going to need is, just like the version we talked about with the timer, if we don't actually remember, this is a good thing to be able to check out as well. If you don't kind of remember exactly how you did something previously or whatever, then let's go look at the other way we did it and see what we can remember. In the timer, we had, it wasn't in here. It was actually in the spawn volumes where we had a timer. And what we did was we had a timer handle, right? And we also had a value for the delay. This is the time delay for the spawning. So we're going to need both of those. We're going to need some time delay and a timer handle. So let's go ahead and create those in the game mode. And of course, we'll make that timer handle, we'll call it F timer handle. This is the power drain timer. And this is going to be access the timer for recurring power draining. And then we need to have a delay between calls to this function. So this is going to be a floating point value, and this will be our power drain delay. And this is a U property, so we want to be able to edit this in the editor, but we're going to be able to edit defaults only again. This is going to be blueprint read only, and we're going to put it in the power category, and we'll mess with that later on when we get back into the editor. So this is how many times per second to update characters, power, and later on we'll check other game rules too. Okay, so that's our power drain delay and the handle to the timer. Then we're going to need the function that gets called by the timer system in order to run these checks. That is going to be a private because nobody else needs access to it outside the class. So that's going to be a void function, and we'll just call this drain power over time. And it doesn't need to take any arguments. So this is going to be what this is the function that's going to drain power from characters and update. And later on, we're going to update gameplay. So we will do more with this function down the road. Okay. Excuse me. Now we need to go ahead and dig into the implementation. So let's flip over to our GameMode CPP file, and let's go ahead and first drop some values into our defaults for the decay rate and the power drain delay. So we need a base value decay rate. Let's go ahead and just set that to 0.02 F. And then we need a base value for how frequently to drain power. And let's say we want to do that 4 times every second for now. So power drain delay equals 0.25 seconds. Okay, so we're all set there. And now we need to go ahead and look, there's our decay rate function for us. So down at the very bottom, we'll throw this new function, GameMode drain power over time. Okay, so the first thing we're going to need to do is we're going to go through the world and get access to all the players. Now, this is going to diverge from Epic's implementation of this in the tutorial, if you've seen that, because here we can't just assume what player we're talking about. We have to iterate through all of the controllers and get a handle to each of those players. And we're going to get that list from the world. Now, typically what we've done in the past, what you may have seen or we've done is say, we would do something like this. We would say equals get world. And then we would check that value to make sure it works and do some code. Now, I'm going to tell you that there's another way we can do this, and it's a little better in terms of performance for shipping titles. And the way is this. If we do this code like this, it's going to get executed. That if check gets executed all the time. But when we get around to shipping the game, we're trying to squeeze out every bit of performance from this thing. You really don't need to do this check, because by the time you get close to shipping, that all should be handled, and this should pretty much be guaranteed to be true. So there's another way that the engine provides for us to do this check, and it is a macro called check. So we do check world, just like that. And what that does is that will actually check the world for us and do what's called an assert. It'll basically just catastrophically crash the game if that is false. And that's exactly what you want, because during development or when you're debugging, if something goes wrong and there is no world by the time you get to this function, something is very wrong in your game. So you really want a catastrophic failure to be forced on it so that you can go troubleshoot the problem. Well, that's what the check does. Then when you get close to shipping and you start compiling your game in shipping mode, that check just gets blanked out. No code gets put in there, and so it gets compiled away and nothing happens. And so you gain a tiny bit of performance because this code is not executed behind that check. So it's great for debugging and great for performance when you get ready to ship. So we're going to use that method going forward. And that's just on certain things. We're not going to do it replace every if check with that. That doesn't make sense. But just for cases like this where we know that world should be valid when you get to this function. So we're going to leave the check, but that's about it. So this is going to access the world to get to the players. All right. Now that we have a handle on that, what we're going to have to do is I'm just going to write a little bit of pseudocode. We're going to go through all the characters in the game, and then for each character that we find, we're going to drain its power. So how are we going to do that? Well, there's a few ways we could do it. Every player has a pawn, so we could iterate through all the pawns in the world, but there could be a lot of pawns, and that may not be the most useful. We also know that this is something that's really only going to be happening to player characters. So in this case, what we'll do is we'll actually use the controllers. And lucky for us, there's already functions and ability for us to grab a hold of all of the controllers in the world. And it's called the fconst controller iterator. So we're going to grab one of those. And where do we get it? From the world, get controller iterator. That's going to give us access to all the controllers. Then, so long as it's valid, we will increment that iterator, just like any other for loop. So we grab the iterator and we start iterating. Now what we need to do is, from the controller, let's make sure that it's a player controller. So we're going to use that a player controller. If a player controller, so we're going to cast this to a player controller to make sure that that's what it is before we start using it. Make sure it's a player controller. We need to dereference it. Okay, so if that's true, and again we're combining the assignment and the if check, then what we need to do is grab the battery characters. We need to get the pawn, because that's where our power functionality exists, is on the pawn or the character. So we need to grab that. So let's go for ANMP game character, battery character, and we get that by doing the same thing. We're going to cast ANMP game character. We're going to cast the player controller's pawn. So we're going to go dig into the player controller, which we just got a handle to. We're going to say, give me your pawn, And once we get the pawn from the player controller, then we're going to cast it to a battery character. And if that works, again, we've combined assignment and the if check. Then we need to go ahead and drain power. So we go, hey, battery character, and we're going to update power. And the math for this is basically we take the drain delay, which is the amount of time that has happened, the time that's lapsed since our last call to this, and we're going to multiply that times our decay rate, and then make that as a percentage of our initial power. So it's got to be negative, so we're taking power away. So we take our power drain delay, and we multiply that times the decay rate, and we multiply that times the battery character's initial power. So we get the initial power. Make sure I got enough parentheses here. Okay, I think we're good. All right, so that is the math for that. Now, one of the things we want to do is we don't want the power to go negative on the player, so let's actually make sure they have power before we take more away. So we're going to do a quick check for the battery character to have current power value, not current montage, get current power greater than 0. Okay, so if they have greater than 0 power, just move that up. Then we're going to take away a little bit of power. Okay, that is pretty much all we have to do for that. Now, as I mentioned, we're going to run this on a timer using the drain delay, the power drain delay as the time between calls. We need to start that timer. We're going to do that in a begin play, which we need to define. So let's flip over to our header, and we need to create the begin play function. Or rather, override the begin play function that gets called on anyway. And that is a virtual function, void begin play override. And this is, we're going to set the power drain time, or start the power drain timer. Start the power drain timer in here. Okay, so let's go ahead and implement this. I'm going to use my quick handy shortcut, which might not be so quick, depending on IntelliSense. All right. And what we're going to do is, actually, let me flip over to the CPP file and do that directly there. So here's our begin play. What we need to do is the same thing we did with the spawn volume. So again, you don't have to remember every single line of code you ever type. Let's go and recall or remind ourselves how we did that. And what we did was we grabbed the World Time Manager and did all this. So in fact, why don't we just go ahead and copy that and flip back over to the game mode, and we'll paste it in there. So we're going to get the World Time Manager. We're going to set the timer, but we have our power drain timer instead. And we are the game mode, and we're going to call drain power over time, and the time is actually the power drain delay. And this is true because we do want it to loop. Okay, so we're going to have that loop. And we will kill the loop later on when we implement some more game rules in terms of handling states. But suffice to say, for now, it's going to stop calling this when we exit the game. So we'll do that. Now, one thing you may have recalled when we looked over in the spawn volume was we do our old authority check. But I haven't mentioned that here in the game mode. Why is that? Well, that is because the game mode, there's only one of them. And it only exists on the server. It doesn't exist anywhere else. So this can't possibly be run anywhere else. So we don't need to put in those checks in this case. Even though, as I've said, that's kind of our standard practice, it isn't necessary here because the game mode only even exists on the server. And in fact, that's going to be the basis of some of the changes we're going to be making shortly. That's just foreshadowing. All right, so we have pretty much everything we need here. We've set our decay rate, and we've created our loop timer using the timer. And in that loop, we're iterating through all of the players and draining some of their power over time. So now we should be able to go ahead and right-click and hit Build, and we'll compile that. And now, if that all works correctly, then we'll be able to flip over to the editor, and we will get started on that side of things. All right, so back in the editor, we are going to be able to do a couple of things. Now, as I mentioned, we might want to tweak the values for the power drain delay or the timers and so forth in the game mode. But if you look at the game mode here, all we have is a class. This is just sort of gives us access to that class. In order for this to work, we're going to need to be able to make edits to it. We need to use a blueprint version. So let's create a blueprint class based on this. And I'm going to actually rename this to the battery game mode. And we'll put in the blueprints folder. And now, let me just drag that over here. We have the battery game mode. And it's open in the full blueprint editor, which we don't need, so we'll just close it. And we'll reopen it. And now it's open with just the properties. And you can see right at the top, now we have access to the power drain delay and the decay rate. Perfect. So we'll go ahead and save that. We're going to leave that for a moment. And now here we are in the editor, and we'll do the same kind of test that we did before to see if power gets drained from our characters. Let's go ahead and we need to set that blueprint version for our project. So let's go into our project settings and then go to maps and modes. Our default game mode is battery game mode. Change that. Okay, and now we can go ahead and hit play, and we will move the character over a little bit, and whoops, let me set everything up here, switch back over to the editor, and where'd it go? Here it is. And we need to find the character. Here's a character. Let's find the power section, and there we can see the power is draining away from our character. So we run around and you can see power going down, 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 down. I'm going to hit E. Bam, we got some more power back. Those batteries all disappear. Of course, with that 2-second delay that we've added because of our effects, which we'll actually get to very soon. A couple of videos, hit some more, and boom, we're still draining out power, but we're able to gain power by picking up batteries, which is exactly what we want. Now, let's say we wanted to make some changes to that, the amount of power that gets drained. Maybe this isn't draining power fast enough, or it's too fast. Let's say we wanted to speed it up so it drains power a lot faster. So let's bail out, and let's go over now to our battery mode, the game mode, and here we have those values. So we can set those, the decay rate to be faster. Let's say 0.04. Let's double it. And then let's say we also wanted this to happen more frequently or less frequently. How would we change that? Well, that's in our power drain delay. That's the number of seconds between calls. So here's another little tip for you in using Unreal Editor. When I want to set the time delay here, this is the number of seconds between calls. So I want the call to drain power to happen, let's say, 4 times every second. Well, that's called the frequency. 4 times per second is the frequency. The number of seconds between calls is the inverse of the frequency. That is 1 over the frequency. So if I know I want this to happen 4 times every second, then I can take 1 over 4 and I get 0.25, because that's how many seconds, or fractions of a second, happen between calls. Now, it would sure be nice if I could just put in the frequency, because that's something I can kind of think about more directly without doing that conversion in my head. Well, luckily, Unreal Editor to the rescue. It will do the math for us. So if we know that frequency, just take the inverse of frequency to get the time delay, then we can say, well, if I want this to happen 10 times every second, all I have to do is put 1 over 10 and hit enter, and boom, it does the math for us and converts it to 0.1. Similarly, if I wanted this to happen, let's say I wanted it to behave like a tick for some reason, and I wanted it to happen 60 times every second, 1 over 60. There. And it does all of the math for us right here in the editor. Pretty sweet. So we're going to go, I want this to happen 10 times a second. So 1 over 10, or 1/10, compile and save. And then I'm going to go back to my editor and hit play. And now I'm going to grab my handle. So you can see time is going by and the current power is draining away more quickly because we increased it, but the numbers are updating in smaller increments and faster because this is happening more and more. Okay, so we can make tweaks to the game mode now, both in terms of how frequently we call this, so what degree of resolution do we need or accuracy. I would still argue that it doesn't need to be that big, so 4 times a second should be okay for now. And then we can also tweak our decay rate. So we have the ability to do that. I'm just going to reset those to default for now. Bail out of that, we're done. And that's pretty much it. So now we have both aspects of using power. The character is able to pick up batteries and gain power, and the game is going along and draining power over time. So now we kind of have this balance. We've got to try and keep our power level up, and later on we'll add some more rules for actually winning the game. But in the immediate future, we want to add some better effects than what we've been doing so far to test just by looking in the logs or looking in the details panel. We are actually going to add some visuals to our little game so far, and we will do that in the next video. So I will see you when we get there.